Hi, in this video, we want to take a look at loading data into R. Okay, so getting data into R frequently is a huge hurdle for beginners with R. Students frequently struggle with this. This was a tripping point for me. I struggled with it initially. Push through. It's not that hard. I know that it can be daunting initially. I hope that this video will clear up some stuff, but ultimately, you just gotta have to like put your nose to the grindstone and push through this. Once this gets going, R becomes a lot easier, like right after you get through this point. Okay, so I want to make I want a piece of advice for you as you work on the homework, as you work on assignments, as you work on your semester project, is that use code for your projects. Don't do things on the console. Don't type things in manually and then just run it line by line. Have an R script, save what you do in a script and save that file. That is the best way to go. And now a lot of the computer science majors is very natural for. Stat majors usually have come across it by now, but if I'm dealing with like social science majors, a lot of times that they haven't had to do this yet, and they might struggle. If you have problems, let me know. I'll work with you. Everything will be good. This is the best way to go. I promise you. If you doubt me, just push through. Please just agree with me for a moment. You don't have to agree with me. Just do it. Just go along with me for the moment, and then push through. It's worth it in the long run. If you're going to be working with data, you have to be working with code. All right, so now why is it that you should use code for loading data instead of the tools that are available in RStudio, or really like Import Wizard and SAS, or other ways to go about it? Well, first and foremost, frequently you're going to have to backtrack on your project. You're going to do something, you're going to discover, oh, that was not the best course of action, or something has changed, and you need to go back and change what you did. Now, if you are loading things manually, going click, click, click with your mouse or some other pointer, then you have to manually go through and do this. If you're doing it by code, you just highlight it and press Control-R. Boom, you got it. Or Control-Enter in RStudio. R GUI, it's Control-R. You highlight Control-R. Now, another reason why we want to do it this way, well, when I save a script, when I save my code, that gives me documentation for what I did. So if I need to re-execute for some reason, I just highlight it, rerun it, boom, I've got it, easy peasy lemon squeezy. If I have questions or there's an error or I have to debug later down the road, I have my code to go back and reference to. I do this a lot. I'll work on a project, 6 months later, frequently I have completely forgotten about the project. I won't even remember I worked on the project. People will be asking me questions about the output. I'll be like, let me get back to you. I look at my code, I see what I did, I'm like, oh, okay. And then I can explain what's going on. This especially gets important when the outcome contradicts like somebody else's point of view, what they wanted to happen. And a lot of times, data reveals things that, we don't actually normally know about. And so I'll be working on something, I'll present results, and someone will disagree because either an opinion or for job security, they disagree. And I need to be able to defend myself in that situation. So my code gives me the best, documentation I have. I can say, I did this right here. This is what happened. All right, so it's super easy. It's much easier to reload your data, answer questions, debug it if you have code. Now, also, another reason why we want to do this is that if I go through and I have to click, click, click to load my data, and I did it manually, I use the tools in RStudio or Import Wizard or something like that, I have to remember what I did every step of the way. Well, if I'm working on a project and it's a big project, I probably won't remember. Also, debugging is almost impossible if you don't have code. If you did things by memory, it's going to be really hard to debug. So I really want to recommend to you that you type out code to do your projects, to do your homework, and then you save that and you keep it. All right, so something that you're going to need is you're going to need the file path. So the file path tells R where is the item you want to grab. So for us, it's going to be like a spreadsheet of some form. So typically it's going to be like a comma separated values file. You know, for a moment, just think of it, if you're not familiar with this, think of an Excel spreadsheet. Well, where is it? So I need to tell R, where do I have it stored so that R can go grab it and then pull it into the workspace that I've got going on. All right, so what you want to do, you want to work with something that looks like this. You see how I've basically a series of folders and subfolders. Eventually I get down to, let's say I want the magazines data set. And this magazines data set is stored as a comma separated values file. It's in the input folder, which is inside the 2021 spring folder, which is in the STA 6714 folder, which is on the desktop, which is this user ID, which is the user aspect of the computer, which is stored in the C. All right, so this tells R where to go looking for the file that I want it to. So to get this long string of basically a computer address inside a Windows machine, that's important. So this is a Windows machine specific command. What I'm going to do, I'm going to type out file.path, and then inside I put choose.files. What this will do, this will open up a GUI. I can click on the files I want, and then when I hit enter on a Windows machine only, it will print this out for me. And so now this is an HTML document. I'm not actually going to run through this because of having to interact with Zoom and HTML. I'm trying to keep this relatively simple for a video. So here's just an example. If I pick this location and I say, hey, I want the file path of this, I'm giving it the file path, so it's redundant, then it'll print this out for me. So what I will do when I start loading my data, I will, including the quotations, I will copy and paste this into my code, and I'll tell R, this is the file I want. Okay, that's gonna be kind of like a reoccurring aspect to what goes on for the rest of the video. All right, now when I'm actually loading data, this is kind of a tricky point for someone who's never thought about this before. What's going to happen is we have to consider how is the data stored. All right, so if you've never worked with data, of course, you've never really thought about this, but the way that data is stored can be surprisingly complicated. All right, so what we can do, what we've got is we've got file types. So one way that we can record data is I have a piece of data, I put a comma, and then I have another piece of data, put a comma, and then I put another piece of data and comma. I do that line by line inside the file. That would be a comma separated file. Well, so because I put a comma to separate individual data points. Okay, well, we could also use like just spaces or maybe a tab as a space in between, or a semicolon. There's also the possibility that I could say that, all right, position 2 is where like the second data field is, position 3 is the third location, and so on. So each different type of file, which is usually specified at the very end of the file path. So up here, this says this is a comma separated values. That's usually a good tip-off. This isn't 100% true, but usually if you see CSV, it's probably a comma separated file set. Okay, so inside R, one of the things that makes R kind of complicated on this point is that there are tons and tons of ways to get the same file into the R workspace. It's going to be kind of difficult, going to be kind of a pain at first, but once you get into the groove, it won't be that bad. All right, I'm going to talk about 3 different packages. All right, so a package is a collection of functions that are useful in R. The first one is the base R package, then read R, then read.table. Base R is what it comes out of the box with R. It's old school, it's well established, you can trust it, it's very reliable, it's gone through the years and decades of use, so you know it's pretty solid. Generally, I mean, these functions were built up a long time ago, when computer science was not as well developed. And you can kind of see that in aspects of the code. So it takes a little bit longer than other options, but it's very reliable. Something that is kind of wonky about it is that the strings as factor settings tends to be a pain in the neck. So just watch out for that. Now, readr is a special package for reading data into R. That's why it's called readr. It's much faster than base R, and it's almost always it's an improvement over the base R corresponding functions. The downside is that you have to load a specific package for it, namely readr. And there's a few things I don't like about it, but specifically column types, but that's not really a big deal. Now, if you're dealing with a big data problem, you have a lot of data and it takes a long time to load it, then data.table is probably your fastest option. Probably there might be other specialized packages that work better, but this is a good way to go. The downside of this is that this has a special syntax that you have to learn. It's not hard, it's not that difficult, but it's special and it's particular. It's a very powerful package, but I tend to not use it unless I have a large data set, just because it's a little bit faster and easier for the human to execute readr or base R. I usually use base R if it's a small data set, readr for anything that's maybe like 3,000 rows or more, and then data.table. Anytime it's going to take a while to load, I start using that one. All right, so we have different functions for each file type. Okay, so in base R, if I have white space separated, I use read.table. If I'm using readr, I want read_table. You see the similarity? And then comma separated value, it's read.csv. And then semicolon, read CSV2. Tab delimited, just delim, or TSV, tab separated values. Now, fixed width format, that's where column position in the document says which field I'm talking about. And usually these are common when you're getting data from like government agencies, and when you're dealing with large data sets, these are a good choice because you don't have to put a separator in there, which adds space, which creates a larger file size. So if you have a large data set that you need to save, fixed width format tends to be a good choice. Now, what if I just don't even know what I'm dealing with, which comes up more frequently than you would imagine? Read_file in the readr package will try to figure it out for you. Use adult supervision if you use that. Double check what happens. Now, if I want to read from a connection, so let's say I'm going to read from a website, I want to use read lines. Now, when I say website, it depends on some very specific things, but this is a good way to go if there's like a table, like a notepad file on a website to grab. And then other separators, if it's some exotic thing, something I don't know about, then read.table or read_delim will work out. All right, so here is a quick example. So if I'm using base R, I can use read.csv. So this is a CSV file, and it is comma separated. So if I open up the file and in Notepad and I look at it, I'll see that the observations are separated by commas. That means I want to use a CSV, read.csv. All right, so here I use read.csv. The file is the file path. Now I got this using file.path, file.choose, like I talked about previously. That's how I got this. And then in general, with base R, you want strings as factors equals false, because the default is to have things as factors. I'll talk about it in a little bit, but generally in the beginning of a project, you don't want things as factors. That's not 100% true, but there's just factors are a pain in the neck in R, just trust me. All right, now if I want to use the readr package, I'm using read_CSV. So here's the function I'm using. Now what I'm doing here with this double colon is I'm saying this is the package it's in, go grab that. So this double colon notation, the first part is where to get the function to work with. I don't need it if I do anything in base R or any package that's loaded into the workspace. All right, so let's go ahead and take a look. All right, so if I do base R and I read the data, here's what I get. And then if I use the read R, I notice that the data is still the same, but there is a difference. So here, this is what's called a tibble. The tidyverse has special data saving format. I don't personally like it. I actually avoid tibbles, by the way. I know that there are people who would scream at me for this, but I feel like a regular old data frame is a better way to go. People have arguments against that because, so I recommend not using tibbles if you can avoid it, just because tibbles are not always backwards compatible. So like with the bnlearn package. But if I look through, the actual data is exactly the same. But you'll notice that when I'm printing it, the tibble has a special format for printing that even, so under the hood, this is the actual value, but to save space, to make it so that I'm not like overwhelmed when I look at it, it's rounding everything off for me, which may be good, may be bad. You don't, you know, I like regular format, but whatever. It's up to you either way. All right, so I just talked about packages. Well, a package is a special collection of functions that I want to be able to use. So to get those packages into my system, I have to have them on my computer. I use install.packages to load or to download everything onto my machine. Okay, so what this does, this tells R to go into this repository and grab this package and install it on my machine. All right, that means it's on my machine. That doesn't mean it's on my workspace yet. What this does, this makes it so that it's active in my workspace. All right, so what would happen is if I run this, when I run this command, I don't need this double colon notation anymore if I do this. Now, to use this function at all, I have to have it installed. But if I don't want to use a double colon, I need to load it as a library using the library command. One thing I noticed is that here, install.packages requires quotations, but library does not. It's inconsistent, but yeah, whatever. All right, so after I do this, every single function in that library is like up and available to me as I work on my projects. All right, now there's a disadvantage to this. If I'm using two different packages and they have a function of the same name, I can get package confusion. What is package confusion? That means I intend to use one version, but I get the other one. Okay, if I have two packages, they have the same function name, and like this has a function that's named something, and this one has a function with the same name as this one. R is going to use the most recently loaded package. Well, sometimes when I have like a lot of things going on, it's hard to tell without manually looking which one's which. So in general, I recommend that you write your functions like this, that you use the double colon to say which package you want to use. This will prevent a lot of problems. This package confusion aspect is not an issue in Python nearly as much because Python forces you to do things that correspond to double colon notation. All right, so loading data from Excel. All right, when I load data from Excel, R really doesn't have a lot of good options. It's just not natural to it. If you've been just kind of getting into R, this can be like a surprisingly difficult thing. Basically, what you have to do, you have to find a package that will let you read an Excel file and then read it in. It's not that hard, but when you first get going, if nobody tells you which way to go, this can be a pain. All right, so here are like the most common options that I know about. All right, the read Excel package, in my opinion, is the best one to use overall in most situations. All right, so here, this function works for almost everything I do. Not 100%, but this is my go-to for most situations. My second go-to when I have larger data sets, or I need to start working with things with a lot of like worksheets, a lot of subsheets in the Excel files. I find that the OpenXLSX package is the best way to go. Now, the XLSX package has a lot of capabilities, but I've encountered problems with memory allocation and with Java. I personally find that it's not worth the headache to fight through, considering these other options are available. GData is another package that has a lot of good flexibility in there if you need to do some specialized work. But for a lot of like regular work with data, I would use ReadXL instead. Now, XL Connect, okay, so this is a good one to use if I need to load data, do something, and then save things like fonts and cell colors and headers and stuff like merged cells and stuff like that. If I need to save aspects of the Excel spreadsheet that really are not the way that like data science thinks about it, this is probably the way to go. One thing that you'll find is a lot of people who are working with spreadsheets, they'll do like some really crazy slick stuff with Excel rather than like doing statistics and math. It's kind of, I find an interesting aspect. I call them spreadsheet rangers, people who just get really good at Excel spreadsheets. They do like arithmetic and think it's slick, but I mean, they get paid. I mean, you can feed your family off of it, but I find it just super boring. All right, so how do I use this? So, so if I want to use ReadXL package, ReadXL function, and this function tends to handle a wide range of spreadsheets for you easily. Like you don't have to worry about, is it the right like version of Excel for what I'm doing? So I just put in the path. I tell it the type of columns I have. So if I put in just text, it will load everything as a text. If I need to have different column types for different columns, then I need a vector for each column. And here I can skip. So here, this is school grades from the 18-19 school year from the Florida Department of Education. So you can see how well like each school district did, how well each school did. All right, now when I'm loading data into R, column names are something that you're going to need to work with. All right, so humans are incredibly inconsistent when it comes to labeling things. And so you're going to end up working with column names to get some consistency. What will end up happening is you'll have a spreadsheet from this quarter, a spreadsheet from this quarter, and one for each quarter. You got 4 of them, and the person working on it gave it different names for each quarter. And you're going to have to clean things up. You'll be working with the column names. One thing you want to do, you want to have syntactically correct column names as much as possible. Now, that's if humans are not going to be looking at the output. The make names function will clean up all of your column names so that they're syntactically correct within R. This is a good way to go. Now, you'll always want to do this depending on how you're going to be presenting things. Sometimes, like for your plots, it's better to not change the names, but I find that this is a better way to go. All right, so remember a column name, columns are vertical. The top row, when I look at a spreadsheet, is the column name, that's the header. If I have syntactically correct names, which are the ones coming from here, I can use this $ technique to extract data. Now, if I don't, I can use this. Now, that is not the correct version of quotations, by the way, but don't worry about it. I can also pull variable, I can pull data this way. This way is faster than the other way. So if I have a big data project, it's to my advantage to use the $ notation rather than this one. Now, another advantage to using make names or making sure that I don't have any white space or any special characters in my column names is that some functions such as random forest will not operate the way I want it to if the column names are not syntactically correct. It'll start throwing errors. Now, R can be very inconsistent on row names. So rows go like this, columns go like this. If you can't remember the difference, columns on building go up and down. Columns on a spreadsheet go up and down. Okay, so row names, depending on the package you're working with, the aspect of row names can change. So some package mandate that you have row names. These are usually specialized for very specific functions. So sometimes it doesn't matter, like R just doesn't care. Sometimes functions will screw up your row names. The tidyverse does this a lot. Watch out for this. So if you're doing anything in the tidyverse, such as the read R package, watch out, row names can get thrown off. So it's best practice to have row names as a field in your data set if you can. Now, when I'm talking about loading data into R or just anything in R, you'll hear a lot of people complain, a lot of computer scientists complain about the speed of R. All right, when you hear somebody complaining about the speed of R, first and foremost, usually they're writing bad R code. This is something, and usually the person isn't even aware of it, because you know what, if they knew they were writing bad R code, they wouldn't be belly aching to announce that they don't know what they're doing. So now, a lot of times, you know, they'll start comparing R to Python. Okay, R and Python, R is faster. But when you consider things like C++, Fortran, and SAS, like these guys are just way faster than Python and R. Python and R, you can think of them as, R is like junior varsity high school, and Python is like varsity high school track. C++, Fortran, and SAS are like the Olympics. That's the difference. So, you know, if we're talking about high school, you know, yes, the varsity track, you know, team is faster than junior varsity, but they're still on a high school team. C++, Fortran, and SAS are like Olympic level speeds. So it's not that big of a difference. You hear people bellyache about it. Usually they don't really know how to make R run faster. The first tip I have for you, first and foremost, vectorize, vectorize, and vectorize. If you know how to write it as a vector instead of as a loop, you will speed up what you're doing. Also, there are special functions that get you around a lot of the things that are slower in R, specifically the lapply, sapply functions. These can speed up a lot of your code if you use these correctly. Apply is slightly faster than loop. So here, lapply, sapply, these apply everything. Lapply gives you a list output. Sapply attempts to simplify the output as much as possible. There's advantages and disadvantages. There's also a vapply, which tries to make it into a vector. This function is good for when I might need to be working on rows or columns. Usually across rows is when I use this. Here, this is when I have like an index and I need to apply a function over all sets of data that correspond to a certain index value. And then cluster apply is parallel processing. And this makes a lot of parallel processing easier. You still have issues that you have to make sure that you don't actually slow things down. But I find that this is the best way to do parallel programming in R is to do cluster apply. My number one tip for speed in R is vectorize, vectorize, vectorize. See me in office hours if you want to know more. Okay, so factors. Here is something that is absolutely maddening about R, factors. Okay, so what R does, when I have categorical data and there's like some kind of order to it, R wants to use what's called a factor to order it. And so what's going on is I have my data and I have the ordering of the data. So let's take a look. Let's say that I've got some months and that's my data set. Okay, or that's, you know, each month. what R will do by default, if I pass this in as a character, when I go to print it, what it's going to do, it's going to put in alphabetical order. So it'll be like April, August, and then down the line when that's an incoherent order. All right, so if I look here, if I go with the default order with that, you can see that April, August, December, February, and so on. It takes alphabetical order by default for categorical data. All right, so if I just pass characters or I pass a factor and I don't specify the order, it's going to go alphabetical. So you can see that this is incoherent. Why would I care about the alphabetical ordering of the months? No, what I want is something that looks like this. January, February, March, April, May, June, July, August, September, October, all the way down the line. Well, how do I get this? All right, so I use factor. So here, this is a categorical data vector. So it's labels, it's names. R doesn't do anything special with it. It just leaves it as is. Now, if I say factor, what it's going to do, it's going to figure out an ordering, and under the hood, when it sees the first level, it actually has a 1, the second level is a 2, and a 3 underneath the hood. And then whenever I'm doing something and it sees that number 1, it takes the first level. So what I want to do is I want to have first level is January. So when I do something, it sees January, it takes a 1 for that position, and then whenever that 1 comes up, it puts a January in there. When it sees a 4, it puts in April. When it sees a 12, it puts in December. That's what I want. Or if I do it this way, it's not going to do it in the right order. It's going to do it in alphabetical order, which is not what I want, because R doesn't know the order in particular. What I need to do, I need to say that the order is the order that I want it in. So here you can see that I've got these ordered out in the proper order. And by specifying that this is the order I want, it knows to put it in this order down here as I have it. Now, remember that I've got, just because there is an ordering to categorical data, that doesn't mean it's ordered data, ordinal data. So remember, first place, second place, third place, that's ordinal data, right? So just because I know that somebody got first place and another person got second place, either that can be like they were close, it was a photo finish, or they were really far apart. Like number 1, number 2 are very separate from just like in different leagues in a competition. And so ordinal data, like we know the order, but we don't know how close they are. And like month data is an example of ordinal data, because if I'm talking about like the 31st and then the 1st, like they're different months, they're close to each other. Or if I'm talking about the 1st and the 31st, that way, then they're far apart. So if I want ordinal data, I have to put ordered equals true. By default, it's not. Different functions in R worry about ordinal data in different manners. Sometimes it worries about it, sometimes it doesn't. You have to look at the documentation for this one. All right, so something about factors. Factors are generally a pain in the neck. You want to keep things as categorical data, like as late as possible, and then you switch to factor. I find that is the easiest way to go. It's usually when I start plotting things personally. That's when, like right before I plot, is when I switch categories into factors. In general, I use ordered equals false in most situations for my work. And factors are actually a more efficient way to store big data, because it's storing it as like a 1, 2, 3 instead of a long character string. Well, that's all I've got for you. Take care and goodbye.